It was 2 a.m. on a summer night. I had just arrived home from a night out with friends when I stepped out of my car and my jaw dropped. The dark sky was lit up with vibrant green flashes, and I stared, mesmerized at the elegant motions. This was my first time seeing the northern lights of the aurora borealis in person. Although my hometown Sudbury is considered part of northern Ontario in Canada, it isn't so far north as to frequently host light shows like this. Auroras are some of the most beautiful cosmic spectacles visible to the naked eye from the surface of Earth. They provide an amazing illustration of the interplay between our sun, 94 million miles away from us, and Earth's molten iron core, 1,800 miles beneath our feet. It's in the core that Earth's magnetic field is generated, and this is crucial to the creation of auroras, which hover anywhere from 60 to 600 miles above our surface in the ionosphere. About 25 years have passed since that night, and I've spent a good chunk of that time studying the generation of Earth's and other planets' magnetic fields. I find it fascinating that most of the conditions we experience that make life comfortable here on Earth's surface, like our magnetic shield, are actually the result of processes occurring deep in our planet, hidden from view. Deep beneath our feet, too, nutrients and volatiles, chemicals that readily evaporate like water and carbon dioxide, cycle and are ultimately responsible for the creation of our atmosphere and oceans. They also guide the regulation of our climate and surface temperature through the carbon cycle. None of those would be possible without the machinations of Earth's deep interior. But there is a dark side, too. Some of the most dangerous natural hazards on Earth, earthquakes, volcanoes, tsunamis, are also the byproduct of deep Earth processes. This gives us all the more reason to try to understand what goes on deep beneath our feet. And as the auroras demonstrate, the insides of Earth also interact with the space surrounding Earth. When it comes to auroras, it's an interplay between the Earth and the Sun. The Sun spews out a torrential wind of fast-moving ions and electrons, known as the solar wind. Those solar wind particles head to Earth at about 1 million miles per hour and would slam right into the planet's surface if it weren't for Earth's magnetic field. But Earth's core generates a magnetic field able to fend off those dangerous high-energy particles. If not for our core, the onslaught of solar wind particles would devastate life as we know it on Earth. These high-energy particles can create cell damage that causes cancer, erode our atmosphere, and induce power surges and blackouts by blowing transmission lines.